Welcome back. Before we compare the three interesting adjectives, let us define one more term which will be useful in that comparison, and that term is entropy produced or entropy production. You may have heard or you may have read in some textbooks that entropy is always produced, it is never destroyed. So what is that entropy production one talks about? Let us define it properly. See, the second law and the definition of entropy tells us that ds, the change in entropy, is always greater than or at most equal to dq by t. I am considering a small process element. Let us transpose the right hand side term to the left hand side and we will get ds minus dq by t to be greater than or equal to 0. That means the left side of this, well, I can't call it equation, this relation is always positive, it is never negative. It is positive in the limit, it can be 0 in the reversible limit, but it can never be negative. This is the term which we can define as the entropy produced. Since we are in the differential domain, we will call it dsp, and hence our definition is dsp is defined as ds minus dq by t. Now this is the defining expression for the entropy produced. This is the name entropy produced, and the second law now gets hidden in this, and hence if you want to properly write second law in terms of dsp, this definition, it becomes dsp must be greater than or equal to 0. This becomes the second law. On the other hand, if you have a process, then for a process we can write delta S must be greater than or equal to integral of dq by t, and in a similar fashion you can write Sp as delta S minus integral dq by t. This will be the definition of entropy produced for a full process, and the second law would be this entropy produced must be greater than or equal to 0. This is the second law. We will write this expression as ds equal to dq by t plus dsp, or we can write this expression as delta S is integral dq by t plus sp. We will use these expressions for the comparison of the adjectives. One thing before we go is to notice that dq for a general process which is considered here is not an exact differential, and hence when you integrate dq we do not get delta q, we simply get q, the heat interaction. Similarly, our dsp, the differential of entropy produced, is not an exact differential. So when you integrate that over a process, you just get the entropy produced in that process, not delta sp, simply sp. Thank you.